The Chapter 3 test. Find the critical points when the first derivative is equal to 0, and use the second derivative test for curvature, at those points. Determine if they are max or mins or neither. Use and show your calculus techniques. Yes, you can just graph and know these, but let's use our calculus techniques. So f prime will be 4 times 3, 12x to the third minus 12x squared minus 2 times 36, 72x, and the derivative of 10 is gone. So since there's an x in every one, I can pull that out, and a 12 goes into all of those, and I'll have x squared minus x plus, or minus, 12 goes into 72 6 times. And that factors to x, let's see, that would be minus 3 and x plus 2 and 12x. So if I'm setting this equal to 0, then x has to equal 0. 3 or negative 2. So those are my critical points, critical places. Now, I need to find the second derivative, f double prime of x. So that would be 36 x squared minus 24x minus 72. If I put 0 in there, f double prime of 0 turns out to be negative 72, so it's concaved down at 0. So we have at x equals 0 is a max place. Concave down makes it a max. Then if we put in f double prime of 3, it's a little bit hard to do, so I'll just type that equation in. And 36x squared minus 24x minus 72. Probably could have factored out 12 out of this and made it easier to do this, but I'll just type that in, second table, and I want to put in 0, and it gave me negative 72, so it's concave down, a place of maximum. If I put in 3, I get 180, which is positive, so it's concaved up, so that's a x equal 3 is where we have a minimum, and f double prime of negative 2 is 120, so it's concave up, and we have another min at x equal negative 2. Number 2. So we're determine the local max and minimums, and we're inflection parts as well. And what is the global max and min on the interval from negative 5 to 0? So let's just take a look at it first. X e to the 0.5x. Let's go zoom 4. looks like it's concave down, then concaved up on the interval from -5 to 0. That's what it said. Well, it looks like the high spot's going to be at the 0. But when we're looking for max and mins, global max and mins also, we plug in the endpoints. So we have to find out what is f of -5. So second table, f of -5 is -0.41. Then we have to find out what f of 0 is. Well, that's going to be clearly 0 times anything is 0. And then we have to know at the critical points. So now we're going to use our calculus to get our derivative. And this is a product, so we got to take the derivative of x times e to the point, I'll just do 1/2 because it's clear, plus the derivative of e to the 0.5x, or 1/2 x, is 1/2 e to the 1/2 x times x. Now, in both of these, there's an e to the 1/2 x. So if I factor out e to the 0.5x, or 1/2 x, I'm left with 1, I have to have a 1 for this one, plus 1/2 x. That's never 0. So this is 0 when x is -2. Because -2 times 1/2 is -1, plus 1 is 0. So at x equal -2 is our only critical. And so we want to find f of -2. And f of -2 is -0.736. 0.736. Okay? And then I think that's all we need, because they want inflection points, so we need to take the second derivative, because that's where the curvature changes. So I'm going to use this to take the second derivative. The derivative of the first is 1/2 e to the 1/2 x times this, plus this times the derivative of this, which is 1/2. Now I could have gone back to here and taken the derivative of this, which is 1/2 e to the 1/2 x, and the derivative of this is the derivative of the original function, so it would have been all of this again. But anyway, we've got it here, and I notice that there's a 1/2 e to the 1/2 x in both of these, and I get 1/2 e to the 1/2 x times 1 plus 1/2 x plus 1 for that one. So this is not as easy to do in our head, so I'm going to set, that's going to be 1/2 x plus 2 equals 0. Subtract 2 and I get 1/2 x equals -2. Multiply both sides by 2 and I get x equals -4. So I want to find f of -4. And I get it's -0.4 negative 0.541. So, but that's an inflection point. So this says the inflection points are at x equals negative 4. The actual inflection point, is minus 4, negative 0.541. And that's not a maximum. Now I got to figure out where the maximums are. And looks like the largest number is 0, so that's the global max. Global min would be the smallest number, which is this one, negative 0.736. And the endpoints are neither global or local maxes or mins. Again, look at the graph. There's a local min and no local max. There's just a low spot there. So there is a no local max between negative 5 and 0. There is no local. There is a low spot. No local max. It's not curved down anywhere. So the local min is at where was it? At negative 2. It's at x equal negative 2. That's good enough for the answer. The point is negative 2 comma negative 0.736. That was the longer problem. Now let's do some easier ones. This says we have positive slope. These are all derivatives. So this is a positive height, so the original graph has got a positive slope, and it's getting a higher here, so it's got a more positive slope. It's getting steeper, and then the slope decreases. So this is curved up and then curved down, but always increasing. Increasing, concaved up and then down. So that's F. This one, this is a negative value, so the original graph has a negative slope, getting less negative, but still always negative, but getting less steep negative. So it must look like this, which is decreasing concaved up. Decreasing concaved up is B. This one is a positive slope, so it's increasing pretty steeply because it's pretty big size, and then it drops down to increasing not so much. So increasing but not increasing so much. So that's increasing concave down. Increasing concave down is D. A farmer is making 3 pens next to a barn, doesn't need to put fence on the barn side. She'll want pens all rectangular and equal in size and shape. So they're equal, they're similar pens. And she has 100 feet of fencing to fence this, 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 and that, and that. What will be the dimensions of each pen if the area is maximized? So I don't know how long that is, or that, or that, or that. And I could put y on each one of these, or I could put y for the whole thing. That doesn't matter. I'll do it this way. So I got 4 x's plus the 3 y's are going to use up the fencing, 100 feet of it. And we want the area of each pen. Each pen has an area of x times y, and we want to maximize that, so we want to take the derivative, but we got 2 independent variables. We need to get that down, so we need to solve for either x or y in this. I'll solve for y. And then I'll divide by 3 to get y completely by itself, and so I get the area is x times 100 minus 4x divided by 3. So I'm going to distribute in the x and undistribute the 1/3. So this is going to be 1/3 of 100x minus 4x squared. So to maximize, I take the derivative and set it equal to 0. The derivative of 1/3 of something stays 1/3 of the stuff is 100 minus 8x. For this to equal 0, 100 minus 8x must equal 0. So 8x must equal 100, and x must be 100 divided by 8, which is 12.5, 12.5, and this is in feet. So there's one dimension. X is 12.5. And to find the other one, y is equal to this, because these 3's cancel. 4 times 12.5 is 50. 100 minus 50 is 50. Divided by 3 is what y is. Cylindrical tank. I gave you the volume formula, and I gave you the surface area. And there's two parts, because if you have a cylindrical tank, it has a circle on one end, a circle on the other end, and there's the two circles, and it has the side around, which is a perimeter times the height. And if the material to make the ends is $11 per square foot, and this is how many square feet, it's the cost for the ends is going to be 11 times 2 pi r squared. And the cost for the side, since it's $7 per square foot, and this is the square footage, it's going to be plus 7 times 2 pi r h. So there's what we got to take the derivative of and set equal to 0 and find the max or min for it. But we've got an r and an h, and they told us the volume is 500, so we have 500 equals pi r squared h. I think we can solve for h pretty easily, and it would be 500 divided by pi r squared. We're going to put that in for h, so this equation becomes 22 pi r squared plus 500 times 14 7,000 pi r over